Hey everyone, so continuing our series about system design, this video we are going to discuss about scaling the server. Under this one, we are going to talk about horizontal and vertical scaling. We are going to see what is stateless, what is stateful server. We are also going to have overview about the load balancer and one more thing, that is API gateway, that is not mentioned in here. We will try to put that also in place. So let's jump back to the diagram that we have. So this is the initial single server setup that we have already seen. This one we are going to expand. So client side, this mobile and browser is going to be similar throughout the series. Database and server are going to be expanded a bit. So let's expand this server a bit. So I'm just copying it and going a bit down in here. Let's say there is a very minimal request coming in, like thousands of requests per minute. Our single server, when we are saying single server, that is capacity is limited. What capacity I'm talking about? So capacity in terms of let's say initially this is the X and then we have CPU. These are the two major considerations when we talk about that load on the server, capacity of the server. So initially we have X amount of memory and Y amount of CPU, and that capacity is able to handle let's say thousands of requests per minute, and that is coming in, it is fine. But what about that request is increasing by 10 times, by 100 times? So what we have to do, we have to basically increment this server. So when we are in single server setup, so this initial increment in number of requests can be taken care if we expand the capacity. Like if it is X, I can multiply it into 2 and CPU. This is not exactly into 2, but just for our understanding we are taking up like double the request and double the capacity. But in actual scenario the number is a bit here and there. So here we have doubled the request, load is coming in, so we have doubled the capacity, that is fine. So whenever a client is going in, so this double capacity server is going to take care of all the requests that is there. Now let's say this is I have like our portal, real estate portal has got very much popular and it is getting the visibility on the user side as well as the builder side also. They are adding their properties and buyers are coming to see the properties on that portal. So again I have to increment that capacity. So to increment that capacity, there is one point also, because existing server we are incrementing it, right? So there is one machine, so I have to replace it with another machine. So there is a kind of downtime, like I have to stop whenever you are using any online banking or anything. So you see sometimes a pop-up or information comes in that the server is going to be maintenance for something. So this time of upgrade also we need that time, we need that window. So there will be, I have to take shutdown, I have to ask our customer to experience some downtime at particular point in time. So that is the one point that we have to keep in mind, that downtime is going to be there when we are upgrading our server. Coming back to the initial discussion, that our number of requests and load has increased tenfold. So what now I have to do, I have to increase the capacity again. So this time I can increase the capacity, let's say initially 2, and now I can increment it 5 times in here, or 10 times I can increase it here, CPU and memory both. So you see this one single server is getting the more and more capacity, and whatever I'm explaining in here, this server we are explaining in here, right? So just consider that as a replacement of this. So you see the limitation of this one, I cannot continue to increase the capacity. There has to be, at a particular point in time, there will be a scenario where I cannot increase this capacity further. So even if the load is increasing, I cannot increase it further. So here you see the limitation. This way of, you see, the way that we are increasing the load, we are putting more and more load on a single server only. So this way of increasing the capacity we call the vertical scaling. Vertical means we are putting the load on the existing system only, so the size is getting increased and increased. So you see the diagram representation of this one. So we also saw the limitation of this one. Now coming back to how can we overcome this one. So let's come down. I'll copy this same thing in here. So I'll come down a bit and paste it in here. So there is also one option. Instead of increasing the capacity of the existing, like doubling the memory, I can increase the number of instances. Like I have one server, I can double it. So now our system can handle double the number of the requests. Our capacity, our load is increasing again and again. So I can go ahead and increase more number of loads in here. More it is increasing more, so I can add more machines in here. You see, horizontally I am putting more same number of capacity, similar capacity, I am adding the new machines. So now the difference from the previous one is that now I am adding more machines instead of increasing the capacity of the existing one. So let's say the load is increased, I can keep adding the machines infinitely. There is no limit here, unlimited number of machines I can put in here. And after a particular point in time, if the load is decreasing, I can just remove those machines from there. So whenever the load is increasing, I can keep adding it. Whenever the load is decreasing, I can keep decreasing the machines. So here there was one more problem. So whenever I have increased the load, it's not possible to downgrade that, because I have already incurred the cost of the big server. If I reduce that, even if the number of requests has decreased, it is not going to benefit at all. One pros of this is that, like, one benefit is there, the simplicity of the single server. You have one client, you can just connect to the one server and it will do the job, that vertical scaling part, single machine. But with the horizontal scaling, that complexity comes in place. So whenever that the actual benefit that is coming in, like unlimited, I can scale it, I can put more number of instances around this one, but that limitation coming in, so how we can overcome that one? To overcome that one, so let me put this aside a bit, just to, so that it's properly visible when I put more component in here. So here let me put this as, take this one as well. So that DNS and all that is going to be there as well, but here for the simplicity I am taking this one. So what is the actual scenario? So now if I keep adding these machines in here, so what is the scenario? Like, this has to connect with all of these one, right? This has to connect to this one, and this has to connect to this one, so on and so forth. So whenever I add machines, I have to make client aware about those machines, but this is not practically possible, that client knowing every machines that I am adding on the backend. So how to overcome this problem? That is where one more component comes into picture, that is what we call load balancer. Very important concept, that is load balancer. So load balancer sits here between client and all the machines that we have in here. So whatever request that client is sending, it will send the request. Now it will send the just have to know the address of the load balancer, and rest of the things will be taken care by the load balancer. Whenever I am adding any new machine, I just have to register it with the load balancer that I am adding this new machine. So what will happen? So it will just know this address, right? And whenever I am removing it, I can just remove it and I ask load balancer that this is no longer there. As simple as that. Okay, so whenever we are talking about this, like putting the load balancer in itself, the name says that balancing the load that is coming in. So let's say this server can handle the request like 100,000 of requests per minute. So this will distribute the load among all of these one equally. So how it is balancing the load, there are different kinds of algorithm coming in, so you can check out the video on the channel itself to know more about those algorithms in there. Okay, so that is the one thing, that where load balancer is coming in. So one more thing, load balancer can balance the load when we have the similar kind of functionality. You see the example that we have took about that real estate, right? So real estate has two kinds of user, majorly two kinds of functionalities are there. So which one are there? So first one, like builders are there, who are going to register their properties, and the second set of functionalities there, that is buyers are going to be there. So whenever the load on, like there are more at particular point in time, it is possible that more builders are registering their properties. So whatever servers that are going to be there for the builders functionality, we can keep increasing that one, and that won't affect on the buyers. Consider another point in time where there is a huge amount of traffic on the buyer side but not on the builder side. So single load balancer cannot take care of that one, because load balancer, what it does, it will distribute the load among the similar functionality. So I have to designate two load balancer in here. Okay, so there will be two LB, I will just name it LB in here, and there will be more. So let's say these are the builder instances and these are the buyer instances that are in here. So whenever this load on this one is increasing, I can keep increasing the number of builders, and whenever this is increasing, I can keep increasing the number of buyer instances in here. So now coming to the problem in here. So earlier with this explanation, we were seeing that client is connecting with the load balancer, but now I have put two load balancer in here. So how the client is going to know about both of these load balancer? That is where API gateway comes into picture. What comes into picture? That is API, and this is a very important and very difficult at the same time interview question, that what is the difference between load balancer and API gateway. So API gateway does the job of routing. Routing means that is different functionalities are there, and it will route whatever client is asking for, it will route the functionality among that. So this is the builder's load balancer and this is the buyer's load balancer. Alright. So how the client will be now the client role is now very much simplified. You see, it just have to know the single address, that API gateway. API gateway has two critical functionalities. First, it is there to route the request based on the request that client is asking for. Let's say builder is asking to add something, it will route that request towards the builder. If buyer request is coming in, it will route that request towards the buyers. Another part is that security it adds. Now whatever is in here, I can privately secure this one, right? So wait a minute. So now this, all of the backend server will go to the private system. What is the meaning of private instances? Private instances means they are not accessible. Even if I know the IP address of this one, I cannot access it if that is not allowed explicitly. API gateway is the only publicly available address that is available. So this is one layer of security and very important layer of security that plays a very critical role on this one. Okay, so that's where this comes into picture. API gateway and load balancer. So I hope you got the understanding about these things, right? So I think there was one more topic to cover. Like we saw the horizontal scaling, we saw the load balancer and API gateway, stateless and stateful server. So let's understand this as well. So as we are adding more number of, so let's let me come down a bit in here. So just to explain it better, so let me serve these ones. So consider this is the two server coming in, and this is the client request that is coming in. Okay, so let's say first request, I am the user, I am logged into the portal, and first request that is there, it is going to be served by the first server. Whenever that second request, and I have explained you also to serve the single request, how many requests the client is sending to the server. There are so many number of requests it is making to load a single page on the UI, right? So let's say first request it had sent to the first server, and second request it is sending again to the second server, and so on. So the problem that it will create in here, like whatever, there will be some logic, some sort of storage that is needed. It needs to store that in memory and to maintain that state actually, right? So whatever servers that we have in here, like putting in here, if our server is storing the state, and it depends on the previous call that it has made, like first I'm logging into the system, whenever after that when I'm interacting with the server, like creating, checking out something, adding something in the cart, so all those activities that I'm doing, it has to know that there is some user logged in already. That is something I have to maintain a state. If this server is trying to make, like trying to store that state, that is what we say that our server is stateful, that this individual server is stateful, and all other requests that is coming in, that was going in here, somehow it has to make sure that this also goes to this server in here. Only then it will be able to successfully serve that request. Otherwise, if that request is going to this one, it won't be able to know that whatever is happening with the previous request. So this is about the stateful. So whenever we have single server setup, this one state, whenever we have this setup, kind of stateful makes sense in this one. But whenever we have this horizontal scaling sort of thing, in that case it is better to have stateless servers. There should not be any state that is maintained in the server. That state can be maintained outside of that server. We will be talking more about like what kind of storage that can be used for the state storage. So whenever any request is coming in, it will fetch that, the client will send some sort of token, some information about that request that is stored in the database. So if that request is coming to this server, it will fetch that state from in here, and if this request is coming into this server, this will also fetch that information from this one. So now we have single state stored where all the servers can communicate. So with that stateful, I can continue to add the loads on this one. I can continue to add the machines in here. There won't be any problem. So stateless, keeping server stateless is very important in case of horizontal scaling. Keep this in mind, and keep this in mind while going for the interview. Difference must be clear very nicely, why it is needed and what benefit it is providing. So just to summarize what all we saw in here, so let me minimize it a bit so that we can see it. So this is the diagram that I want to present here actually. So there is this database connectivity as well, so just let's make it. Database also, we are going to expand this database a bit. Okay, so this is the picture that I want you to take from this one basically. Our client is there, so let's add this in here as well, that DNS call that is there, otherwise you will say that there is something missing. So this will just get that IP address, it will request to the API gateway, and then load balancer, builders, buyer functionalities are there, then database connectivity is going to be there. Okay, so and the stateful, stateless, API gateway, load balancer, we got the practical understanding why they are needed. Actually, that is the main purpose. I hope you found it useful. In the next video, we are going to talk about database, different kinds of databases, and how we can scale the data. Let's say we talked about scaling of the database. Like, so database also has a limit, right? Let's say our database has limit about X amount of memory and Y amount of CPU that can store a limited amount of data, right? So but when the number of requests from the client side is increasing, the load on the database will also be increased, right? So when we have taken care of the capacity handling on the server side, we have to do the similar thing on the database side as well. Let's talk about that scaling on the database side in the next video. I hope you found this useful. If so, please don't forget to share this video and subscribe the channel. See you in the next one. Till then, take care. Bye bye.